Cade Metz. You are a reporter with the New York Times, and you cover artificial intelligence, driverless car, robotics, virtual reality, and other emerging areas. And today, we will speak about your first book, Genius Makers, the Mavericks who brought artificial intelligence to Google, Facebook, and the world. Kate, thank you so much for joining us today.
Glad to be here. Thanks for having me.
So, Kate, Kate, the first thing that attracted me about your book was the cover. I mean, you said never judge a book by its cover, but congratulations to your graphic designer. I think it's very, I mean, it's the kind of book that if I'm walking in the bookstore, whenever they will open one day, I will grab out of curiosity because it piques my, yeah, it piques my curiosity right away. I wonder if we could start by you telling us a little bit about yourself. We all I know is that you work for the New York Times and you cover this area, but how do you get to be a reporter or interested in becoming a journalist?
Well, I often say it goes all the way back to my childhood. I grew up in Raleigh, North Carolina, on the East Coast of the United States. And my father was an engineer and a programmer with IBM. He worked for IBM for almost his entire career. One of the projects he worked on that everyone can relate to is what they call the Universal Product Code, the barcode that's on all your groceries. That was developed at IBM in the 70s, and he helped test that project. And he had these incredible stories about the development of that technology, but also about how it made its way into the world and the reaction from people to this new technology. There were actually protests outside grocery stores in the 70s when this was deployed because people saw it as the sign of the beast from Revelations in the Bible. I loved, even at a young age, to hear those stories and to think about not only building the technology, but pushing it out into the world. My mother, on the other hand, was very much a reader, someone with an English major's sensibility, and I majored in English in college and always wanted to be a writer. And then sort of in a natural way, I melded those two pieces of myself, and technology is what I write about. And certainly the type of people like my father are who I love writing about the most. And you can see that reflected in the book.
It's funny how we are all afraid of technology when it first comes out, and then it becomes such an essential part of our life that we cannot live without. Like if you think back of the Industrial Revolution, when industrialists started creating these machines that could weigh material, and then people were afraid what's gonna come with our jobs, and people started burning down those factories and destroying it. And the barcode that your father, where your father was working with, I think I heard an interview about him in national NPR a podcast or something like that. And yes, that's something that frightens a lot of people. And the same with the teller machines at the banks. People say, oh no, this is the end of the world. And then we cannot live without that. It's just crazy.
Right. And now sometimes those fears that we have over the technology are over exaggerated, right? And sometimes they're not warranted. In other cases, they are. And my book goes into that. You see the places hopefully where the fear is unwarranted, and the places where it is. There are a lot of big questions that we need to think about as all sorts of technology is deployed. And I think that's going to get more important in the years to come because the technology is getting more complex and more powerful and more a part of our daily lives.
Right. And after World War One, I think the British economist John Maynard Keynes predicted that his grandkids will only work 15 hours a day, and then we will have a 5-day weekend or something like that. And yet, people who have the know-how because they are passionate about it, they are working 40 to 60 hours a week. And people who don't have the know-how because they cannot make ends meet, they are also working 40 to 60 hours a week. So this fantasy that one day technology will help us. I mean, it's helping us every day, but it seems that it's not improving our day-to-day life in giving us more leisure time to enjoy ourselves and the things that we would like to do as humans.
No, it's true. It's very hard to predict the future, right? Even in the near term, the far term, it's certainly even harder. And, you know, it's interesting you bring that up about Keynes. You're right. There's this group of people now that they talk about what's called the universal basic income. And they're going to have to set aside money for the population at large because they're not going to have jobs to sustain them. But these machines that we're building are somehow going to create an economy where the money is generated and then just freely distributed. There are a lot of people who do believe that right now. There are a lot of people who push back against that too. And as the technology stands today, it's hard to see how that's going to happen in the near term, to tell you the truth. And my book tries to give a realistic picture of what has happened so far, what the technology can actually do versus what is still aspirational. And, you know, it's all driven by people who have varying opinions, who are very different in their own ways and bring their own personalities and experiences and ambitions to this technology. And so even though you'll get two people working on the same basic technology, they will see it completely differently, and they will see the future of it completely differently. That's always fascinated me. And I think it's a good way to give people a proper perspective of the technology if you can see it from different angles.
Okay, so going back to your past, how is it then that you gravitated towards technology writing? What was your first breakthrough and you ended up now working for the New York Times?
Well, I moved to New York right out of college and was looking for a job in journalism. I got a job with what was then the biggest computer magazine of the day, PC Magazine, as a researcher, which meant I fact-checked stories. For the first 6 months or so I was there and worked my way up to being a writer. I eventually ended up at Wired Magazine on the West Coast and did that for 5 or 6 years, and then from there moved to the New York Times. And so I've been with the Times now for about 4 years, and I'm very glad to be there.
And are you working remotely right now, or do you usually live in New York, close to New York Times headquarters?
I am actually, I'm in California where I live, and typically I work out of the San Francisco office of the New York Times. So we have what we call a bureau here in San Francisco, which is pretty big nowadays because there's so much to cover in terms of technology right here, right? Our Google Beat reporter is here, and the Facebook reporter, and many other people who cover Silicon Valley, just because this is the heart of the U.S. tech industry.
And then, okay, so how the idea of this book came about?
Well, it's funny. The idea kind of ebbed and flowed as I put it together. I initially pitched the book to my publisher after coming back from Seoul, South Korea, where I had been in 2016, to see this machine that had been built by a team in London at a lab called DeepMind. They built a machine to play the ancient game of Go, which is the Eastern version of chess. Very popular still in Korea and China and Japan. But Go is exponentially more complex than chess. And in 2016, many people in the field of AI, as well as people in the Go community, which is a very large community in Asia, very fervent community, believed that we wouldn't see a machine that could beat the best players at this game for decades to come. Because the top players play by intuition. It's not like chess where you can systematically look ahead at moves in the game. You see the top players play by feel. They talk about this. You can't necessarily look ahead because it's so complex. And if you're going to build a machine to beat the best players, you're going to have to mimic that type of intuition and that type of playing by feel. And DeepMind, this lab, was able to do that. At this event in Korea, at the Four Seasons Hotel in Seoul, this machine beat one of the world's best players, a guy named Lee Sedol, he's almost like the Roger Federer of the Go world, the best player of the past decade. And the machine ended up winning. And I came back to the States resolving to write a book. And in part because of the technology and the response to it, and the progress you could see in that type of technology, which could be applied to so many other parts of our world. But also, I was intrigued by the leaders of this lab, and in particular, a guy named Demis Hassabis, who founded this lab in London. He became a key character in the book. And what I found as I pulled the book together is that there was a small group of people over the decades, really, who really believed in this one idea that was driving, that Go plane machine, but also driving so many of the other technologies that were coming to the fore. And this is an idea that dates all the way back to the 50s. And I realized there was a great book, a narrative book, to tell about this tiny, incredibly interesting group of people, each interesting in their own different way, and how their stories wove together and how their personal sensibilities drove the technology forward, and then eventually clashed with these very large tech companies. DeepMind was acquired by Google. So many of these companies, as the technology started to work, just snapped up this talent, and you saw this kind of clash of ideals, and that became the second half of the book.
Okay, so your book is mostly about the characters who created or pushed forward artificial intelligence. Yes, yes. Can you define artificial intelligence? I mean, we all have a sense of what it is, but yes, can you frame it in words?
That's a good thing to do. I really think it's a confusing term, to tell you the truth. It's something else that dates back to the 50s. This group of people got together at Dartmouth College in the US in the late 50s, and they coined the term. Their aim was to build a machine that could do anything the human brain could do. And so they called it artificial intelligence. What people didn't realize, what they didn't realize even then, was that they were so far away from doing it, that it was far harder than they expected. But they put that term out into the world. When you hear that term, you just assume that we're talking about something that works like our minds work. And we didn't have that in the 50s, and we don't have that now. It's a term that gets applied to all sorts of technology that maybe vaguely works like the brain, and maybe is a small step towards something that mimics our minds, but we're not there. So I really think you have to pull back from that term and really look at the specific technologies and how they're built and how they're starting to work. It gets dangerous when we take that term and just apply it to everything. I think it's confusing to people and misleading.
Right. Okay. So, great. And then you have two, what I see as two main characters. You just mentioned one of them. I don't know how to pronounce his last name. Demis Hassabis.
Hassabis.
Hassabis. Okay. And Geoff Hinton, the man who couldn't sit down. Can you tell us a little bit about him and why he couldn't sit down?
He is a fascinating character. And as I came back from Korea and started to build the book, the center of gravity for the book became him. And you learn in the first sentence of the book that he does not sit down. He says, I have not sat down since 2005. And it was a mistake. And it was a mistake. And what he means is when he was a teenager, he was lifting a space heater for his mother. This was post-war Britain, and it was this very large space heater basically filled with bricks, and he slipped a disc. And as the decades went by, the problem with his back grew increasingly worse. He would slip a disc time and again, and each time he did, it would really lay him up for weeks on end. He was a professor, and his students tell these stories about coming into his office, trying to defend their thesis or whatever else, and he's laying on the desk or on a cot by the window, right? It got to be a serious problem. So what he says is that he decided one day the only way to manage it, the only way to keep this disc from slipping, was to stop sitting down. And what that means is he can't drive a car. He can't fly in an airplane, at least not with the commercial airlines, because they make you sit during takeoff and landing. But what this became was a real metaphor for the book. Like I said, there's this one idea. It's called a neural network, and we can go into that. It dates back to the 50s, and it's driving so much of the technology in this field that's really working now. He grabbed hold of this idea in the early 70s and continued to work on it, even in the face of enormous skepticism and enormous difficulty. And his back problem plays into this. He's basically makes these pilgrimages across North America to try to get this technology to work and get it into these large companies. And he's got to ride the train. And once he gets off the train, having traveled from Toronto to Seattle, say, he's got to get a taxi and lay down in the back of the taxi to get anywhere that he wants to go. But it became a metaphor for his struggle, really over the decades, to realize this one idea.
Okay, that's so funny. I see that many artificial intelligence is driven by many people who are not from the United States. In fact, people say that China is a copycat of U.S. technology, but I see them as a leader in the industry. So how can you explain how is that happening? Because I mean, if we look back 20 years ago, they were still trying to copy the United States in almost everything, even how to make a automobile. And now they all of a sudden they leapfrog, and now they are leading in this industry.
That's one of the reasons I began the book like I do, right? There's this scene as the book opens where this technology, this idea of a neural network starts to work. And Jeff Hinton, he sees an opportunity, and he literally auctions his own services and the services of two of his students off to the highest bidder. And the bidders are some of the biggest companies in the US, Google, Microsoft, but also from that moment, that key moment in 2012, one of the biggest companies in China is a bidder, Baidu. And you're right, China is there from the beginning of this new revolution and saw what was happening. And they've become a very important player in the field. But you're right, it's not just China. Jeff Hinton was born in London, grew up in Britain, came to the United States and worked here for a time in the 80s, but then left for various reasons, which will become very important, left for Canada. And so the center of gravity for this idea that suddenly became so important and was so, such a big part of what those companies wanted to do, all the talent was not in the US. It was in Canada around Jeff. It was in England around Demis Hassabis, who we talked about. Other parts of Europe, China was pushing ahead with this, as you talked about. And so what you saw was kind of a real effort to capture this talent. And what that meant is that the US really needed this talent from outside its borders. It's something that people may or may not realize, that in science and technology, and this has been the case for a long time, the US really relies on immigrant talent. And it is certainly true in this field. And we need to think about that as as time goes on, and we think about how to compete with our rivals, right? China is in some ways a rival, of course, but also the U.S. relies on Chinese talent as well as talent from other countries. And if we say, bar entry to those types of researchers, we're hurting ourselves.
Right.
So it's a complicated situation. I think that you're very right to highlight that.
So you live in Silicon Valley. You are not only exposed to science, but you are also exposed to the world of investments. As a person who is looking to where to allocate my next $1,000, what should I be looking for in the news?
Oh, well, I'm not one to give financial advice, but what I will say is that the type of things that I'm writing about in the book, right? What we're seeing, that one idea I keep talking about, called a neural network. It's a mathematical system that learns its skills by analyzing data. So the example I always give is, with a neural network, you can feed it thousands of cat photos, and it analyzes those photos, and it looks for patterns that define what a cat looks like. And in that way, in analyzing all those photos, it can learn to recognize a cat. And that's a key development, right? And what it means is the systems can learn their skills in ways that we humans could never teach them, so to speak. We could never, no matter how many engineers we put on the problem, put all these engineers in a room and say, okay, rule by rule, line of computer code by line of computer code, define what a cat looks like. The engineers can never quite get there. It's too hard to do that. But when the machine can learn on its own in that way, it can get there. And that's what we've seen, right? That's the idea that Jeff Hinton believed in. And that idea drives not only image recognition, so say face recognition systems that can recognize faces in images, or a self-driving car. This is how a self-driving car can recognize pedestrians on the side of the road, or a street sign. But this is also what you see when you open up your iPhone and you speak commands into Siri, and it recognizes the words that you say. That's a neural network. It's trained by hours and hours and hours of spoken words, and it looks for the patterns that identify the words that we speak. And you see this same idea working in so many other areas. It's driving a new form of robotics, not just with self-driving cars, but flying drones and machines in warehouses that can sort through items, say an Amazon warehouse, which have become very, very important to us during the pandemic, right? We get all this stuff shipped from across the planet to our doorstep. It's got to go through these warehouses, and it gets put into these giant bins, and then you need people, for the most part, to sort through all that stuff and get it out. But now we have machines that can learn that task and perform it. That's another area of progress. I could go on, but what you're seeing and what the book shows is that you have this one idea, which has been around since the 50s. It's now started to work, and the implications are enormous. It's moving into our lives in so many different ways.
Okay, so the leaders right now, what I want to ask you, who are the biggest players? You mentioned Google, Facebook, and other companies. So are those the leaders right now, or are those the ones who are, have the biggest volume, but maybe there is a new company that is not known as well, and maybe we should be keeping an eye on it?
Those are the leaders right now, for various reasons. Part of it is that the reason that idea never worked before and is working now is that we needed lots and lots of data, for one. We needed the internet to come along and give us the images to train those systems. And we needed the spoken words, and we needed the text that the internet gives us to train these systems. All that is inside these giant companies, right? Because they run these internet services. They also have the computer power needed to analyze all that data. Those are the two things we needed in decades past that we never have. And now we have them, and they're inside Google and Facebook and Amazon and Microsoft. So those companies have a real advantage there because they have those two things, the computing power and the data. So when it comes to really pushing this idea forward, they do have an advantage over others. Now, the technology that they built, and this is, partly because of people like Jeff Hinton, who were academics and moved into these companies, and they wanted to continue to publish their research the way they had done in academia. A lot of these ideas, and even the software that gets built, gets openly shared, right, the way an academic would. And so this technology has a way of trickling down to other parts of the industry and labs across the world. So there are a lot of ways that startup companies or academic labs can still play a big role here, but those big companies do have an advantage.
I had a few guests in the podcast who are concerned that one day they, according to their books, very soon, I think it's just way too far into the future, one day artificial intelligence and automation are going to take over all the works, and we will have nothing left to do. And of course, we have seen with time that as technology advances, it creates new jobs. But I wonder, where do you stand on that?
Well, what I will say is that at the moment, we're not seeing that phenomenon play out. Right? This technology that I'm talking about, it works in very specific areas. And even with something like, say, self-driving cars or the types of robots that I talked about in warehouses, those are places where the technology, the economy kind of needs that. If you look at, say, self-driving trucks, which is probably going to get here first before we have robo-taxis, as you might call them, that the number of truck drivers in the U.S. is actually on the decline. There's not enough people to satisfy the market, so there's actually a real need for those types of self-driving trucks. Same thing in the warehouses, right? Those are becoming more and more important. And it's hard for these companies often to find the labor that they need to fill those jobs. And so, again, there's a need for those robots in that situation.
Well, okay, so last question. Let's say a 17-year-old kid asks you, Cade, what should I study now? I'm about to graduate. I want to contribute. I want to do something in technology. I want to contribute to humanity, and I want to earn lots of money. So what would you tell him?
Well, this is the field to go into. It's called machine learning or artificial intelligence or whatever term you want to use, but it's this idea that we can build machines that learn tasks in this way. That is the field to go into. That is the future of technology, whatever term you want to apply to it.
Okay, well, the last question, can you tell us one more time the title of your book and where can people follow you?
It's called Genius Makers, the Mavericks who brought AI to Google, Facebook, and the world. It's available everywhere. Amazon, your local bookstore. There's an audio version, digital version, as well as hard copy. It published in the UK as well. So there are all those versions there, but also all the way across North America, US, and Canada.
Okay, thank you so much for your time.
Glad to do it. Thank you.